Okay, so here's what have we got? A anti-differentiation by recognition. So first part, the derivative of e to the x times sine 3x plus 3. So just, I guess it's not super clear in the question, but sine 3x plus 3. Yeah. So we've got two different functions, two different representations of x. I suggest it's a product rule. U equals e to the 3x, v equals sine 3x plus 3. So u dashed will equal. In fact, I might make I'm going to just make it sine 3x. Because that 3 is a constant and we want it to disappear as quick as we can. So v is equal, v dashed equals, so what's the derivative of e to the 3x? It's just 3e to the 3x, v dash, derivative of sine 3x. Derivative of sine is positive, so it's 3 cos 3x. So my product rule is just simply derivative of one times the other, derivative other times the one. So let's go, therefore, dy dx is equal to e to the 3x times 3 cos 3x plus the derivative of the second function, 3 cos 3x times, hang on, derivative of the second function, let's undo that. Derivative of the first function, 3e to the 3x times the first function sine 3x. So that means the derivative of that is just equal to, what do you want to do? I don't think I'm going to worry about factorising, so let's just write it as 3e to the 3x times cos 3x plus 3e to the 3x times sine 3x. So don't forget that that's what dy dx is equal to. All right. Hence find an antiderivative of that expression there. So the hence part suggests that we need to work with that derivative. So my first step is always, instead of rewriting the whole thing, I'm just going to cheat a smidgen. X. If I anti-differentiate everything, okay, then I'm going to get what? Let's bring that down. So I get the antiderivative of dy dx dx is just y equals the antiderivative of, we'll bring a 3 at the front, of e to the 3x times cos 3x dx plus 3 at the front, e to the 3x times sine 3x dx. Okay, so let's just go back one step first. Some of you might think I've just sort of forgotten about that 3. Well, don't forget the derivative of a constant is just 0. So whilst that plus 3 isn't anywhere mentioned here, as soon as I differentiate 3, I get 0, which is why I've omitted it. So y is equal to, I need to find an antiderivative of this expression. So let's sort of take a little slight segue. Let's come over here a fraction. This is what I'm looking for. So let's find, I'm looking for the antiderivative of, bring the e to the 3x, 3e to the 3x times sine 3x. If I expand that bracket, minus the antiderivative of 3 sine 3x dx plus the antiderivative of 3e to the 3x cos 3x dx. So let's have a look. If you like, that's expression 1 there. All right, now this minus 1 term is that expression here, and 3e to the 3 cos x is that expression there. So they're the three things that I'm looking for. That's what the question is asking me to find. How does that compare to what I've got? Well, 3e to the 3x sine 3x is that expression there. So I've got that one. The green term I don't have. What about that red term? 3e to the 3x cos 3x is that term there. So if I decide just down here to subtract, oops, let's get rid of that tool. If I decide to subtract that expression on this side, integral of 3 sine 3x dx from that side, and I do the same on this side, sine 3x dx, let's just rewrite it, equals integral of 3e to the 3x cos 3x dx plus 3e to the 3x sine 3x dx minus the integral of 3 sine 3x dx. So hopefully you can see here that this expression here is now exactly the same as that expression there, and that's equal to y minus the integral of 3 sine 3x. So y we know is here, okay? So y is equal to, I'm going to put e to the 3x sine 3x. Now I reckon the 3 is optional. I'll tell you why in a minute. Now subtracting green minus the antiderivative of 3 sine. So the antiderivative of sine is negative cos, and negative is a plus. 1 on k, so I get 1 cos 3x plus some c, and that's equal to that right-hand side, which is what I'm after. So the only thing that we've got that I think is a little bit negotiable here is that c value there, and that 3 and that c could be the one expression. Okay, with the 3 there, it just means my c value might be slightly different if I sub an initial condition in. If I don't have it there, well then that's fine too. Okay, so look, involved sort of question first up. But yeah, you've got to really practice these integration by recognitions. Righto, let g of x equal cos 2x and f of g of x equal natural log of cos 2x. So straight away you can see that we've substituted that cos 2x into the log function. So I'm thinking f of x is equal just the natural log of x. And then if I put cos 2x in there, that seems to fit okay. Find the derivative of f of g of x. So the derivative, we have only one representation. We've got two different functions, but there's only one x there. So that sort of says to me chain rule. So if I put u equal to cos 2x, u dashed is equal to negative 2 sine 2x. And if I put y equal to natural log of u, then dy, I won't write it that way. We'll say y y dashed is equal to 1 on u. Therefore, f dashed of g of x, not even sure if that's the full name, is given by 1 on u, what was u? Cos 2x, times u dashed, which is negative 2 sine 2x, which is equal to negative 2 sine 2x over cos 2x, which is negative 2 tan 2x. Hence, find an antiderivative of tan 2x. Well, that's promising, isn't it? I need an antiderivative of tan, and my derivative has tan in it. So, from part 2, I think it is, no, from part B, I know that dy dx is equal to negative 2 tan 2x, which means then if I integrate both sides, I take the antiderivative, I'm going to get antiderivative of dy dx is just y. I get y is equal to negative 2 times the antiderivative of tan 2x dx, which means the integral of tan 2x dx is equal to y over negative 2, which is, what was y? Y is f of g of x, which is negative 1/2 natural log of cos 2x, okay, plus some constant c. All right, so there's our y recognition process again. Find the antiderivative of the function. Okay, so that's what we've got. Find the antiderivative. So I've got that 2x plus 5 to the power of 5 dx. So we've got the rule off our formula sheet. Add 1 to the power, divide by the power, and multiply by the coefficient of x, which is 2, plus a constant. So what I get 1/12 of 2x plus 5 to the power of 6 plus some constant c. All right, what have we got here? The shade of right angle triangle in the row below, blah, 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 has one vertex at 0, 0. So that's there. Second point at A0, which is there, and the third point at AB. You can see we've got a nice right angle triangle there, haven't we? Okay, show that the area of the shaded triangle. So what is the area of the triangle? So area is equal to 1/2 base height. So now notice with the show question, I haven't looked at this at all. Not interested. All right, I want to get my own. The base is A times the height, which is the B value, which is the y coordinate. That's the trick. Remember, that's just the y coordinate. And the y coordinate there is the point A, 1 minus A on 5. So times 1 minus A on 5. So I get A on 2 outside of 1 minus A on 5, which is equal to A on 2 minus A squared on 10, which is what is required. Okay. Find the maximum area of the shaded triangle. Find the maximum. To find the maximum, I need a derivative. So DAD, lots of A's. The area with respect to E is equal to 1/2 minus 2a on 10, and the maximum occurs when that's equal to 0. So the maximum at dA equal to 0. So I get 2a on 10 has to equal 1/2. 2a is equal to 10 on 2. So what's that mean? A is equal to 5 on 2. Find the maximum area. So the maximum area occurs at A equal to 5 on 2. Area is equal to 5 on 2 on 2 minus 5 on 2 squared over 10, which is 5 on 4 minus 25 on 4 on 10, which is 25 on 40. So 50 on 40 minus 25 on 40 is 25 on 40. So check, find the maximum. Therefore, max area is 25 on 40. Have we got any units? Have we got is 25 on 40 units squared, and it occurs when A equals 5 on 2. All right, so what have we got here? Find the exact area enclosed by the graph. As soon as we have an area, we need a graph. So blue function, e to the half x, so it's just the e to the x graph. So it's something like that. And at x equal to 0, y is equal to 1. And the line x equal to 1. So x equal to 1 is, we'll say there. And the positive x and y axes. So I'm looking for this area here. So area under a curve, 0 to 1 of f of x dx. So that's what it is. So let's work that out. Antiderivative of e to the kx is 1 on k. So I get 1 on k, which is 1 on a half, times e to the half x between 1 and 0. 1 and a half is 2. So I get 2e to the half minus 2e to the 0, which is 2e to the half minus 1, because e to the 0 is 1. Okay. The graphs with the equations are given here. Right. Find the x-coordinates of the points of intersections of the two graphs. Righto. So we need, what do we need? We need e to the 2x equals 6 minus e to the x. So I get e to the 2x plus e to the x minus 6 is equal to 0. So believe it or not, that's actually a quadratic expression. If I put u equal e to the x, u squared is e to the 2x. So I could write this as u squared plus u minus 6 is equal to 0. So I get u plus 3, u minus 2 equal to 0. Therefore, I get u equal to negative 3, u equal to 2. Now, since u equal e to the x, so let's put out, therefore, e to the x equals negative 3, or e to the x is equal to 2. So this one there has no solutions because e to the x can't be negative. If I change the base here, I get natural log of 2 is equal to x. So that's the x coordinate. So that point there is at the point natural log 2. Okay, so now to find the area of the shaded region, I need the top line, area between curves, top graph minus bottom graph. So I need I need the integral between 0 and natural log of 2 of the top graph minus the bottom graph dx. Yeah, so just that integral, natural log of 2 of 6 minus e to the x minus e to the 2x dx, and you differentiate 6x minus e to the x, 1 on k, between natural log of 2 and 0. So that's equal to, substitute natural log of 2 in, 6 natural log of 2 minus e to the natural log of 2 minus 1/2 e to the 2 natural log 2 minus, put 0 in, 0 minus e to the 0 minus 1/2 e to the 0. So what do I get? 6 natural log 2 is just that. Now, e to the natural log 2, so e to the log base e, they're the inverse of each other, so that's just equal to 2 minus 1/2. Well, if I bring that 2 up there to get 2 squared, that's the same as 2 natural log 2 is 2 natural log 4. So that's just the half of 4. Subtract minus 1 minus 1/2. 6 natural log 2 minus 2 minus 2. Minus a minus is a plus. 1 minus 1/2 is plus 3 on 2. So I'm going for 6 natural log of 2 minus 4 plus 3 on 2 is minus 5 on 2. So that's certainly something we could check on our CAS to make sure I haven't made any mistakes. But we'll assume not, hey? All right, last one for now. Find the derivative of the natural log of sine x. So again, two functions, but only one x. Chain rule. U equals sine x. U dashed is equal to derivative of sine, which is cos. So if y is equal to natural log of u, y dashed is equal to 1 on u. So then dy dx is equal to, what is dy dx equal to? 1 on u times cos x, which is equal to cos x on sine x. Okay, hence evaluate. So again, here's our little cos x on sine x that we don't have a rule for, but it's in the derivative. So again, so if I take an antiderivative of all sides, that will leave me with the integral of dy dx dy, y is equal to the antiderivative of cos x on sine x dx. So, because I've got a 3 here, therefore 3y is equal to the integral of 3 cos x on sine x dx. So using that information here, this integral now, well, the antiderivative of 3 cos x sine x is equal to 3y. So that means then that this, therefore, it's equal to 3y, which is 3 natural log of sine x, evaluated between pi on 2 and pi on 6. So let's leave the 3 at the front. So it's 3 outside of, let's put pi on 2 in there. Natural log of sine pi on 2 minus natural log of sine pi on 6, which is 3 times sine of pi on 2 is 1, natural log of 1 minus sine of pi on 6 is natural log of a half, which is 3 times natural log of 1 is 0, negative natural log of a half, and if you remember, that's the same as 3 times negative natural log of 1 minus natural log of 2. So that's 0, minus or minus is a plus, which is the same as 3 natural log of 2. That answer's fine, but just be aware that if you're asked to express in the form a natural log b and a, b are greater than 0, well, you've got to get into this form, don't you? Next one. All right, let's keep going. Given that, blah, 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 find an antiderivative of. All right. So let's start with, we've got derivatives and antiderivatives. So again, let's just give yourself some more landscape. So I'm thinking, let's take the antiderivative of f dashed of x dx is equal to the antiderivative of, I'm going to take that, what do I want to do? I want to take the negative 1 on 2 out the front of that term to give me x over the square root of 1 minus x dx plus the antiderivative of the square root of 1 minus x dx. Is that fair enough? So all I've done is taking an antiderivative of everything here on both sides, because now the antiderivative of f dashed of x is f of x, so I get x square root of 1 minus x is equal to negative a half of minus x dx. Now, I'll just write it as 1 minus x to the half dx. So it's this here expression in red that I'm looking to get an answer for, isn't it? I want to find an antiderivative of that. So if I just keep plotting away, I've got x square root 1 minus x. I'll leave the half here, and in fact what I'll do is, that's what I'm trying to get on its own. And the antiderivative of this is what? Well, I've got a rule for this. Add 1 to the power, divide by the power, and multiply by the coefficient of x. So let's go x square root 1 minus x. I've got a negative sign there, so it's going to be a 2/3. I'm going to make that a plus 2/3. 1 minus x to the 3 on 2 equals negative a half of x over square root 1 minus x dx. So if I multiply now both sides by negative 2, that negative cancels, and 2 times a half is 1. I get negative 2x square root 1 minus x minus 4 on 3, 1 minus x equals x dx. Okay. Now, it is possible that I think that's the answer. It says find an antiderivative of that. I'm happy with that. We could muck around in here and get a common factor. So I could take the square root of 1 minus x out the front as a common factor. And in fact, I'll take a -2 out the front. And what does that leave me on that first bracket? That would leave me with just an x on its own. And it would leave me with a positive 2/3. Well, if I take 1 minus x to the half out the front, I get 1 minus x left over. Yeah. So look, I truly believe we wouldn't have to worry about doing this in an exam. Which is equal to -2 square root 1 minus x times 2/3 plus 1/3 x. We might take a third out the front. So we'll get equals -2 on 3, 1 minus x to the half times x plus 2. So, look, if you want to practice a little bit of algebra, it's nice. But, as I said, here's the end of the question, and that's our answer, okay? Let's have a look. For the graph shown, 1 on x, x squared on 8 are shown right. The region enclosed by the graphs of blah, blah, blah. Find the area of the region. So again, I've got top line minus bottom line, haven't I? So the bottom one is blue, the top one is green. So I've got to find this point of intersection. So first things first, if I put 1 on x equal to x squared on 8, cross multiply, I'll get 8 is equal to x cubed. X is equal to +2, which sort of fits in, so that's nice. So the area between the curves is the area between 1 and 2 of top line, which is x squared on 8 minus bottom line, which is 1 on x dx. So let's just check that. 1 to 2. Oh, I've got it the wrong way around, haven't I? Got it the wrong. Good thing we checked. So we won't worry about erasing and starting at green. Green function f of x, 1 on x minus blue function g of x, x squared on 8. Let's just check that again. Top line, 1 on x, that's better. Okay, so now we've got integral of 1 on x is the natural log of x. Let's undo that, only because we just kept the colour. So that's equal to the natural log of x minus, add 1 to the power and divide, all between 2 and 1. All right, so now I'll just put it all in. So I get natural log of 2 minus 2 cubed is 8. Subtract in brackets, natural log of 1 minus 1 on 24. Natural log of 2 minus 8 on 24 minus a minus plus 1 on 24. I get the natural log of 2 minus 7 on 24. Looks okay. Move on. So, All right. All right, the graph of is shown the normal to the graph of f at the point where x equal to 2 is also shown. Normal line. What does that mean? Normal. Therefore, the gradient of the normal line is -1 over the gradient of the tangent, isn't it? So I can work out, find the equation of that normal. So I need the gradient of the tangent. The gradient of the tangent. So I need the gradient of curve. So f of x is equal to 2x to the minus 1, which means f dashed of x is equal to multiply by the power, take 1 from the power, and at the point we're interested in is at x equal to 2, f dashed of x is equal to -2 on 4, which is -1/2. Therefore, the gradient of the normal is -1 over -1/2, which equals +2, which at least looks reasonable. At least the normal line has a positive gradient. So what does that mean? I've got the equation of the normal is equal to 2x plus c. What's the point the line goes through? Well, it goes through the point 2, and if I put at x equal to 2, y is equal to 1. So I know that I get 1 is equal to 2 times 2 plus c. c is equal to -3. For equation of the normal is equal to 2x minus 3, which I think that sort of seems quite feasible. -3 down there. Looks like it might be a possible y-intercept. So confident we've got that one. Find the area of the region enclosed by the graph of the normal described, the x-axis and the line x equal to 2. So there's x equal to 2. So let's sketch that in there. Because let's try and work out what they're saying. The line x equal to 2 is the point of intersection. Find the area enclosed by the graph of the normal, the x-axis. So I reckon it's just this little area here. Yeah. So look, we could go with some calculus, but I think it's the area of a triangle. So let's just put in some values. That point there is the point 2, 1. So I know the height of the triangle therefore must be 1. I need that distance there, which is that x-intercept. So for the normal at y equal to 0, what do I get? I get 0 is equal to 2x minus 3. 2x equals 3. So 3 on 2 equals x. Seems reasonable. And area is equal to 1/2 times base times height, which is 1/2 times. Now the base is just the distance from 3 on 2 to 2, which is 1/2. And the height was up to the y value, which was 1. So what's that? Equal to 1/4 units squared. Okay. What else have we got? No, part C. Last question. Yes, of course, there's 2 bits. Find the antiderivative of. Okay. Step 1. Let's put everything as the power. So that's x to the 1/2 plus e to the 2x dx. Okay, add 1 to the power. So we get x to the 3 on 2 over 3 on 2 plus 1 on k e to the kx. So over 2/3, that becomes 2 on 3 x to the 3 on 2 plus 1/2 e to the 2x plus some constant c. If f dash of x is that, find f of x. So, all right, so we know that f of x will equal the antiderivative of sine 3x dx. So f of x is equal to, now we get 1 on k. Now the antiderivative of sine is negative, so that's a cos 3x plus some c. And we know at x equal to pi, y is 4/3. So we get 4/3 is equal to minus 1/3 cos of 3 pi plus c. C is equal to 4/3 plus 1/3 times, what's cos of 3 pi? So 3 pi is 1 pi, 2 pi, 3 pi is there, cos is negative, so it's negative 1. So we get 4/3 plus negative 1/3, which is equal to 3/3, so C is equal to 1. Therefore, f of x equals, well, I might write 1 minus 1/3 cos 3x. Okay. Find an antiderivative of that with respect to, that's fine. So the minus 1 part is just a phase shift, so it doesn't affect anything. So an antiderivative of that is just the antiderivative of sine 3x minus 1 dx, which is 1 on 3 derivative cos 3x minus 1 plus some constant c. Okay? Evaluate that. All right, so derivative of the bottom is 2, and we want that to be the top, so we get our log. So let's write that as integral between 0 to 2. That's 1 over 2x plus 1 dx. But if I multiply that by 2, which means I have a half out the front, now I have 2 over 2x plus 1. The derivative of 2x plus 1 is 2, so that fits my log law. So it's a half natural log of 2x plus 1 evaluated between 2 and 0. So I get a half out the front of natural log 2 in there is a 5 minus natural log of a 0 in there is a 1, and natural log of 1 is 0. So I get a half natural log 5. Job done.